Hello everyone, I am Janapati Shrino. Who are watching first time my video, subscribe my channel and share to your friends. In previous video, APPGCET 2021 chemistry question paper, we discussed about 1 to 50 questions. Now I am going to discussing about 51 to 100 question. So question number 51, right? What is that? Which of the following exhibit geometrical isomers, right? So for any geometrical isomers, to exhibit the geometrical isomers, either it should be either like cis-trans isomer should be present. So we will see the options. So option number 1, what is that? C double bond C given here hydrogen. This is hydrogen, and next one is CH3. Second one is bromine, right? What is the second option? Here CH double C, you can write like this: C double bond C. CH3 and H is there, right? CH3 and H. If you will consider here hydrogen, so they given it is as CH2Br. So option number 3, what is that? Here C double bond C. Here you can observe C2H5. Then here hydrogen. So you can observe here C2H5 and C2H5. And finally fourth option is, right? What is that? C double bond C, here hydrogen, and here one more hydrogen is present, here CH3 and here hydrogen. So if you observe clearly, so already I told you whether it is geometrical or not, we have to say like it should be like cis or trans, right? So if you will consider, we can't say because it is a cis or trans, because in same carbon two groups are same, hence we will not distinguish whether it is cis or trans, right? So if you will observe here CH3 is there, here hydrogen. Two are different. These are trans form. It is also exist as cis form, right? So it is also exist as cis form. Here these are hydrogens are opposite. Here these are opposite. So if hydrogen is also, we can write here. So hence option 2 is the correct. If you see option number 3, C2H5 and the same carbon have the same group. Since it is also not geometrical. Here hydrogen. So this is the concept behind the geometrical isomers, right? Simple concept. On the same carbon there should be a different groups should be present. Whatever it is the groups, there should be a different groups, right? Next question number 52. 52, right? What is that? In any two atoms or groups bonded to a chiral carbon atom are interchanged on Fischer projection formula, the resulting isomer is called, right? Resulting isomer. If I say, for example, this is the CH3, this is the ethyl group. If I will take here hydrogen, this is the chloride. So one more example I am taking, same CH3, this is the ethyl. So now this is the hydrogen, this is the Cl you can take. Cl you can take, right? And this is the hydrogen. So this is called chiral containing single carbon. Chiral containing single carbon. So just this is hydrogen, this is a chloride. If you observe, if you interchange these two, what happens? Chloride and hydrogen. So hence these are called the enantiomers. Enantiomers. So just remember, I will discuss these and these two are the enantiomers. So simply you can remember, if odd exchange means only like one time you are exchanging, 3 times you are exchanging, 5 times you are exchanging. Like when you are odd exchanging means we are exchanging only one time, hence it is called enantiomer. If you exchange even number of times, like 2 times, 4 times, 0 times means we are not changing, so hence it is called identical. So what I mean to say that if you will take odd exchange one time, if you will take 2 times means again this comes here, you will get the identical structure. So this is about Fischer projection. So answer is enantiomer. One more concept I forgot to discuss in this. Same, if they will ask the same, like if, for example, here CH2OH is there, here hydrogen, this is the chlorine, this is the hydrogen, this is the bromine, if I will discuss. So for this is a carbon number 1, this is a carbon number 2, right? So if I want to say that even exchange, right? even number of times exchange is present, then it is identical. Identical means like even numbers already we discussed, both carbons, this even is one carbon, this even is second carbon. If we will change even number of times, that is identical structure. Odd is enantiomers. Enantiomers means first carbon only one time you are changing, chloride hydrogen. So if I will change chloride hydrogen here, what I will get? CH2OH. So here first I am changing chloride hydrogen. This is first odd. Second means odd means second time, bromine hydrogen. So if you will observe, these are the mirror images, non-superimposable mirror images. So you can say simply it is enantiomer. So how you will remember? So these two are exchanging, right? Next, even odd. Even odd or odd even is diastereomer. Odd even is diastereomers, right? Diastereomers. These two means this should be even times. So this should be only one time changing, 3 times changing like this. So that is the concept. You should by heart the concept, easy concept, right? Next question number 53. What is that? Decreasing order of reactivity of alkyl halide in SN2 reaction, right? Already we know that. What is SN1 reaction? SN1 reaction is nothing but tertiary, right? Tertiary halides are more reactive than the secondary than primary. For SN2 it is simple. For SN2 reaction, first primary, then secondary, then tertiary. What is the option present? Primary halide, secondary halide, tertiary halide. Means methyl halide. They are given in the form of methyl halide. So primary is nothing but CH3, CH2. This is Cl, primary halide. Chloride I am taking, or X you can take. So this is called primary carbon. Means only this carbon is attaching to only one carbon is called the primary carbon. This is X, right? So this is the one more CH3 if I will take. This is the another CH3. So this is called secondary, means this carbon is attaching to the two alkyl groups. Hence it is a secondary. Now what is the final third? This is CH3. If I will take CH3, this is CH3. And this is called the, because tertiary carbon means 3 carbons are attaching. So next first option they given is methyl halide. This is called super primary. You can say super primary. Answer is methyl halide is super primary. So hence methyl halide, primary halide, secondary and tertiary. Option 1 is the correct option for this question. Simple concept only. You should just remember SN1 is a tertiary more reactive. For SN2 is a primary is more reactive. Then question number 54. What is that? When tertiary alkyl halide and tertiary alkyl azide undergoes Curtis rearrangement, the intermediate formed is, right? So here it is not alkyl azide, so it is acyl azide, right? Acyl azide is RC double bond O N3. N3 means you can write N triple bond here N. N plus you can write, N minus you can write. So this acyl azide, so in presence of base something you can write, it gives what? Curtis rearrangement is R, you will get RN double bond C double bond O. Isocyanate as a product. Isocyanate as a product means, so the intermediate they asked, right? What is the intermediate? How you will say? If this R is comes here to here, so then this is undergoes what? What happens? This N2 is removed and minus is comes here. You will get the R attached to N, then it is double bond, then C double bond O, isocyanate, right? So but before that, actually some does not exist mechanism is there, means the mechanism does not exist in this case. So how you will write this? Whenever this N minus N triple bond N is there, directly you should write here, then remove this, you will get. So actually directly you will write, you will get before that this N plus this N2 is removing, directly you will get RC double bond O N minus, nitrene as intermediate. Nitrene as intermediate. This nitrene is traced out by using H2O. You will get the hydroxamic acid. You will get the hydroxamic acid as the product. By trapping the mechanism, you will get the nitrene as a product. So this is for Curtis rearrangement. So what is the intermediate involved in this? So nitrene as the intermediate. Next, 55. Question number 55. What is that? Predict the product. What is the reaction they given? CH3 here, CH, double bond CH2, then plus HBr, absence of peroxide. Absence of peroxide is nothing but H2O2. I am going to take peroxide. So here generally, here H plus Br minus exists. H plus and Br minus. In the presence of peroxide, that undergoes the anti-Markovnikov rule. In the presence of H2O2, it undergoes the Markovnikov rule. But whenever absence of H2O2 is there, it undergoes the in presence of H2O2, it undergoes the anti-Markovnikov rule. In absence of H2O2, it undergoes the Markovnikov rule. What is the Markovnikov rule? This bromide ion, the negative addendum of the nucleophile, going to attach at the less number of hydrogens or more number of substitutions. What is the Markovnikov rule statement? The negative addendum of the nucleophile undergoes negative addendum of the nucleophile going to react with the carbon containing less number of hydrogens or more number of substitutions. This is the less number of hydrogens, this is the more number of substitutions. This bromide is going to attack here. What you will get? CH3, CH, here Br you will get, and this hydride is H plus is going to attack here, and you will get the CH3. This is the product you will get. What is the option number? 1 is the correct. Next, question number 56. All these are simple questions only. 56, right? What is that? Ylides react with aldehydes or ketones to give the alkenes. This reaction is referred as the. So we will write the first ketones I am writing. If I will take the ketone here, what is the ylide? Ylide, you should know this. CH2 minus, generally it is, and a PPH3 plus. PPH3 plus. PPH3 plus. So this is going to attack here, means so PPH3 double bond O is removed and CH2 is going to attack. The product is, you will get double bond O, double bond CH2. This is called ylide. This is called what? Witting reaction. This is called Witting reaction. Means aldehyde or ketone. If it is aldehyde, you can take it hydrogen. Aldehyde or ketone, in presence of ylides, it forms the what? Alkenes. That is double bond CH2 is what? Alkenes. Hence it is a Witting reaction. Direct reaction, named reaction, and the name of Witting. Next, question number 57. What is that? Replacement of diazonium group by halogen Cs. This is the diazonium salt, N triple bond N. This is N plus. This is the diazonium salt. Replacement of what they asked? Replacement of diazonium group. This group is replaced by halides. Means we should take in the presence of copper chloride and HCl. Copper chloride, bromide, whatever it is, halide you should take. So you will get the product is diazonium is removed. The replacement of diazonium by halide is called the Sandmeyer reaction. Sandmeyer reaction. Sandmeyer reaction. Option 2 is correct. Same, for example, in place of copper chloride, if I will take the HBF4, you will get the only fluoride. Except fluoride, you will take the reagent is F. This is called what? Schiemann reaction. Schiemann reaction, right? So in options they given the Gomberg reaction. What is Gomberg reaction? Gomberg reaction is nothing but diazonium salt react with the what? Benzene. It gives to what? Diaryl compound. Diaryl compound is called the diaryl or diphenyl compound is called what? Gomberg reaction. And the Sandmeyer reaction just now we discussed. Already Witting reaction we discussed in the previous problem. And what is the Woods reaction? Rx plus Rx in presence of sodium in dry ether. Sodium in dry ether, what happens? this R and R get forms the RR, alkane. This is not a double bond formation, alkene. Next, question number 58. What is that? Which of the following statements best describes the disconnections in retrosynthesis? This question belongs to retrosynthesis process, like disconnections approaches, and that is their separate unit. So what is the statement? Statement is a disconnection involves in a theoretical disconnection of a bond in a target structure in order to identify simpler structure that could be linked through the formation of that bond. That is the correct option. So for example, if I will take CH3, C double bond go CH2, CH3. So if I want to make the product, so I will make the simpler, like I will remove this and I will take only this product and I will add here X. Means, so for example here one more X is there, like something. So this is the one product, this is a target molecule, this is another target molecule. By adding this, so means we are just disconnecting the bonds and we will make it the simpler. This is a theoretical process. Option 1 is correct. Next, question number 59. What is that? For the electronic configuration 1s2, 2s2, 2p4, two of the possible term symbols are they given already, singlet S and triplet P. What is the remaining they asked for, right? So what is the configuration? 1s2, 2s2, 2p4, right? 2p4. So whenever you are making the term symbol, just focus on the, this is a filled one, only take the outer one, right? What is the 2p? 2p is nothing but this one. Only how many electrons? 4 electrons. 1, 2, 3, 4 electrons. This is +1, 0, -1. ml values I wrote here, azimuthal values. So if I will take 1 into 2, these are the 2 electrons are there. 1 into 2 is 2, plus 0 into 1 is 0, minus 1 into 1 is -1. You will get the 2 minus 1 is 1. So L value is what? 1. L value is 1 means which term it is? L value 1 is P term, right? So here singlet electron 1, 2 unpaired electrons is there, automatically you should write 3, because otherwise you can write 2s plus 1 in of P. What is 2s plus 1? 2 into what is the S? This is half, this is half. Total is 1. 2 into 1 plus 1. Directly it is P. 2 into 1 means triplet P. Nothing but whenever 2 unpaired electrons is there, the spin should be triplet P. So one of the triplet P is correct. So if they will write, so one of the possible term, right? This is the one of the possible. If I will take like this is a +1, 0, -1. This is the 4 electrons. I am writing 1, 2, 3. Otherwise, I will write like this. I am writing 4 electrons here. This 1 into 2 is 2, -1 into 2 is -2. 2 minus 2 is L value is 2 minus 2 is 0. L is equal to 0 means S term. So nothing is there means 1 electron. Nothing is there means you should write here 1. Otherwise you should write 2s plus 1. 2s plus 1. 2 into what is the S value is 0. 2 into 0 plus 1. So of S. So 2 into 0 plus 1 of is nothing but singlet S. 2 terms are finished. 2 terms we done. Next, what is the possible next possible term? I can write here next 2 double bonds here. One plus 1, 0, -1. If I will write this is like this and this is, for example, if I will write here the electron, if it is I wrote like this, what happens? One into 2 is 2 plus 0 into 1 is 0. You will get what? 2. Same like L is equal to 0 means S term. So otherwise you can write here one more electron is here, you can write like this +1, 0, -1, right? Here I am writing 1 electron is possible here, right? It is possible or not? Possible. Then here it is also possible. So next, here I am writing 2 electrons, right? So if I will write like this, 2 into 1 into 1 is 1, you will get, otherwise better to write here only. So what you will get, 1 into 2 is 2 you will get, right? 1 into 2 is 2 you will get. Here if you will write here minus 1, so what happens here? Minus 1 electron I should write. So if I want to write, so what is the L value 2 means? You can write one of the possible term, right? 3 possible terms are there, right? 3 possible terms. So 4 electrons, we have the 4 electrons. 1 I am writing, 2 I am writing, 3 I am writing here, and 4th if I will write here also, L value SPDF, right? SPDF. So L is equal to 2 means the value is 0. The L is equal to 2 means the value is D, right? So right, I will write here like this. These are the L value is 2. L value is 2 means do one thing, you should write like this, no problem. So when 1 into 2 is 2, then this is the value is, here the value is, you can write here like this, 1 into 2 is 2 and 0, you will get what? 2 into 2 plus 0 is what? 2 only. L is equal to 2 you will get. L is equal to is D term, hence you should write, this is also like this, okay. L is equal to 2, there is no unpaired electron, singlet D. This is a one more possible. This is generally, it won't exist because they asked only possible term, singlet D is answer. Next question number 60. What is that? In a rigid rotor, distance between the two particles is, in a rigid rotor, this is a 1 particle hydrogen, this is a 1 particle chloride. The rigid rotor, the distance between the two particles is constant. What is the distance is constant in the rigid rotor. Next question number 61. What is that? Primary nitroalkanes react with nitrous acid to form the nitroalkanes. I am taking RCH2NO2. This is the one nitroalkane. So react with HNO2, nitrous acid. This HNO2 I am also writing here like O double bond N. This is OH. Simply you should write H2O is removed. So you should write the same structure, RC double bond O NOH and remaining NO2 is as it is. This is called nitrolic acid. Nitrolic acid. Option 1 is the correct option. Simple reaction. Next question number 62. What is that? Which is not true about determine errors, right? Directly determine errors are the not reproducible. This is also very important concept. Next question number 63. 63. What is that? Which of the following element will not be able to liberate hydrogen from dilute acids? Hydrogen from dilute acid. Dilute acid is H plus, right? So to liberate the hydrogen gas means, so dilute acid, for example HCl is there. What is that? H plus plus Cl minus. This H plus by gain of electron, it can convert it into hydrogen. So that means here H plus undergoes what? Reduction. Just you should remember, oxidation takes place at anode, reduction takes place at cathode. Oxidation takes place at anode, reduction takes place at cathode is a spontaneous reaction which liberates a gas. But here H plus undergoes reduction. So if I will write, this is the hydrogen value is 0 in the electrochemical series. So above is the negative values, like what is the negative values options they given? Highest value is potassium, then next is zinc, then next is lead. These are the negative values. So below is copper is the plus, copper is the positive. Just remember negative, so lowest reduction potential undergoes oxidation. Oxidation takes place at anode. So highest reduction potential undergoes reduction. So here if you will observe here, what is the question they asked? Which of the following elements will not be able to liberate? Means it should not be a spontaneous reaction. So for spontaneous reaction it is negative, it is positive. So means one should be highest, is second is lowest. So if I will take hydrogen here, H plus border. Here generally H plus is undergoes reduction, means H plus undergoes reduction means above should be oxidation. Those is a spontaneous reaction. So here you can observe H plus is reduction, but copper undergoes again here. Copper means they given the copper metal undergoes what? Copper plus 2 electrons. But it is a oxidation reaction. It is a oxidation reaction. But according to our concept, so the lowest value, this is the highest value. Lowest value should be undergoes oxidation. But here copper undergoes reduction. Highest value undergoes what? Reduction. But here what happens? Undergoes oxidation. So hence it is a non-spontaneous reaction. Hydrogen gas is not evolved. If you want more clarifications, see my electrochemistry videos. Next, question number 64. What is that? The structure of diborane contains, right? What is the structure of diborane? This is the borane, this is the boride. Diborane is nothing but B2H6. B2H6. We will write the hydrogen here, this is a hydrogen, this is a hydrogen, this is a bridge is hydrogen, this is the hydrogen. So diborane contains, so here this is a two-centered, this you can say two-centered 2 electron bond, means these are the two bonds. This is what? Two centers, 2 electrons. How many are there like this? 1, 2, 3, 4 are there. Next, 3 centers. This is the 3 centers, means 1, 2, 3 centers. This is 1, 2, 3 centers, and 1 electron. 3 centers, 2 electron, means this. What is that? What is options? 4 are 2 centered 2 electron bonds, means like 1, 2, 3, 4. 4 are 2 centered. 4 are 2 center 2 electron bonds, and this is 1 3 center 2 electron bond. It is called. This is one more 3 center 2 electron bond. This is also called banana bond. So how many are there? 2 3 centered 2 electron bonds. These are called 3 centered 2 electron bonds. Otherwise, I will give one formula for you. So for 2 centered 2 electron bonds, half into B plus H. For 3 centered 2 electrons, number of boron atoms. Number of boron atoms. So for if you apply the formula B2H6, what happens? Half into, what is the number of borons? 2 plus, how many are there? Hydrogen 6. So 2 plus 6 is 8. 8 by 2 is 4. So we will get the 4 2 centered 2 electron bonds. And the number of boron atoms is 2. So we will get the 2 3 centered 2 electron bonds. This is about diborane concept. Next, question number 65. What is that? 65, right? The interconversion of hexatriene to cyclohexadiene by electrocyclic reaction. Hexatriene is I am writing here. This is a 6 member 1, 2, 3, 4, 5, 6. This is the hexatriene. This is converted into hexadiene. Cyclohexadiene means this bond is going here, this bond going here, this bond is forming here. Means it should be appearing like this. This is hexadiene. This is the 4n plus 2 system. 4n plus 2 pi electron system means, so 1, 2, 3. 3 means, so here you can say 4 into, how many, for example, if I will take 4 into 1. 4 into 1 is 6 pi electron system. It is a 6 pi electron system. So I will give one conclusions for this. You should remember 4n con is thermally, this is allowed. This is not allowed. Not allowed. 4n con is thermally allowed. 4n this is, just these you should by heart. If it is 4n con thermally allowed, 4n this is photochemically allowed. Photochemically allowed. 4n plus 2 con. This already thermally allowed means automatically this is photochemically allowed. 4n plus 2 dis rotation is thermally allowed. Means here thermally allowed means photochemically not allowed. This is thermally not allowed. This is allowed means thermally not allowed. This is photochemically allowed. Based on this conclusion, this is the 4n plus 2 system. Means option should be here only. 4n plus 2, either it is be con, or if it is 4n plus 2 con rotation, this is allowed. 4n plus 2 dis rotation, this is allowed, this is forbidden. So we will see the options. I am not going to discuss first option, so I will discuss first option otherwise. So first option is thermally allowed in disk rotation. Thermally allowed. This is thermally allowed disk rotation. This is the correct option. We will check the second option. Thermally forbidden in disk rotation. Is this forbidden in thermal disk rotation? So wrong option. Next, thermally allowed in Kahn rotation. This is thermally allowed in Kahn rotation, but it is disk rotation. So wrong option. Photochemically forbidden in Kahn rotation. This is we have to see in the Foreign-Pressure system, right? So photochemically forbidden in the Kahn rotation mode. Photochemical. This. So I will discuss one more time. So first option is thermally. What is that? Thermally allowed. Thermally. What is it? Thermally allowed in disk rotation. Thermally allowed in disk rotation. We don't consider these two. Only you should focus on thermally allowed in disk rotation. First option is correct. And second option, thermal forbidden in disk rotation. This is the disk rotation. Thermally forbidden they are asking, but it is photochemically forbidden. So wrong option. Next, thermally allowed in Kahn rotation. Thermally allowed. This is the thermal and allowed in Kahn rotation. Wrong option because it is disk rotation. And fourth option is photochemically forbidden in Kahn rotation. Photochemically. This is the photochemically forbidden. Photochemical. This is the wrong option. Photochemically forbidden in Kahn rotation. This is also wrong option. This is about question number 65. Option 1 is the correct option. Very simple concept. Just you should by heart this Woodward-Fisher rules. These are called the Woodward-Fisher rules. You just by heart it. Next question number 66. This is a theoretical model. So if heat Q flows reversibly from the system, the surroundings at T0 means entropy increases the surroundings in Q by T0. Entropy the system is reduced to Q by T0. System has lost entropy to the surroundings. So all options are correct for this question. Next question, the theory oriented, I am not going to discuss in detail. Question number 67. How does the volume of 1 mole of an ideal gas change if the temperature and the pressure are both decreased by a factor of 4? So what is ideal gas? PV is equal to nRT. But here N is 1 mole they given, right? So what they asked? Pressure and temperature. Both pressure and temperature decreased by 4. Means pressure is decreased by 4 times, means P by 4 of pressure. So initially pressure is P. So it is decreased by 4 times, means P by 4 into V. And temperature is also decreasing 4 times, means T by 4. So 4 cancel, you will get PV is equal to RT. Means PV is equal to RT, PV is equal to RT. So hence there is no change, means remains unchanged. Next question number 68. What is that? The rate determining step in Michaelis-Menten kinetics is. So if it is an enzyme, if it is a substrate, this undergoes reversible reaction. This is K1, you can say K minus 1. This forms the initially enzyme substrate complex. This bracket represents the complex. So this complex undergoes K2, I am writing rate constant, undergoes, you will get the enzyme plus product. Sorry, you should write product plus, you should write the product here. Means, so what is the option? The complex is, what they ask, rate determining step is this. This is a slow step, rate determining step. So the complex dissociation step, this is a complex dissociation step to produce the products is the correct option. First, option number 2 is the correct further. Next, question number 69. This is from electrochemistry. Directly we can say that for a reaction zinc plus 2 electrons, it undergoes, it gives to zinc. E0 value they given. Which of the following statement is nothing but, so the E is depends upon temperature. From next equation already we know that E is equal to E0 cell minus 0.0591 by N into log of concentration of products by reactants, means temperature. E cell is equal to E0 cell minus, so 2.303 RT by NF log of concentration of products by reactants. Concentration of products by reactants means this is depends upon the temperature. E is depends upon the temperature only. Next, question number 70. What is that? In Freundlich adsorption isotherm, the value of 1 by N. What is the Freundlich adsorption isotherm? Adsorption X by M is directly proportional to P power 1 by N. You can say, right, X by M is equal to K into, if you remove the proportional symbol, K into P power 1 by N. This 1 by N value is in between the 0 and 1 in all cases is the correct option for this question. So generally from this they will ask the what is the low temperature, high temperature, high pressure, low pressure condition, what is the rate, they will ask this question. Next question number 71, right? What is that? Which of the following does not react with Hinsberg reagent? What is the Hinsberg reagent? Hinsberg reagent is phenyl, you can say sulfonyl, phenyl sulfonyl chloride, phenyl sulfon, it's not phenyl, like aryl sulfonyl chloride, you can say. So in presence of primary amine, if I will take primary amine, like this is CH2 or alkyl I will take, okay. So NH2 I will write. This is a hydrogen, this is NH, this is what? R group I will write, NH2. So this hydrogen and this Cl gets removed. It forms what? Phenyl. So this is aryl. Benzene sulfonyl, you can say benzene sulfonyl. This is what? The remaining is NHR. So this is soluble in the alkali. This is upon getting, this is soluble by reacting with NaOH. It is soluble in the NaOH. Same if I will take in presence of primary, this is a primary. If I will take secondary is this is R, this is R, this is one more content, it is a hydrogen. So if you will get what is the product? NN dialkyl. What is the product you will get here? I am not writing the complete ring. S double bond O N H. So already H is removed, right? N. This is R. So NN dialkyl. So benzene sulfonamide, benzene sulfonamide, you can say. So this is insoluble in the alkali. If it is second one is insoluble in the alkali. And if you will take the tertiary, it does not contain the hydrogen. It does not contain the hydrogen means this is a tertiary amine. It does not contain the hydrogen means so it does not going to react. So that is what they asked. Next question number 72. What is that? 72. Assertion: if the temperature does not affect the rate of reaction, EA is equal to 0. If temperature does not affect the rate of the reaction, EA is equal to 0. So this is a true statement, and lesser the activation energy, slower will be the reaction. So it is wrong option because this is what? A reactant. This is what? Product. So the extra energy we are giving to is called the activation energy. So EA, this is called EA energy. So if EA energy is more, for example, if EA energy is more like this, it is taking more time to process, it is more time to get the product. But what they asked, EA and this EA energy and product is rate is inverse proportion. So but what they asked, if EA is more, if EA is less, slower the reaction. If EA is less, so it is more product. Reaction is very fast. If EA is more, it is forms late, very late. So hence this is the false statement. So option 3 is the correct assertion and reason. Next, question number 73. What is that? The next equation, E is equal to E naught minus RT by NF ln Q. Indicate the equilibrium constant Kc will be equal to Q when. So generally this question is something like the question was given wrong because for equilibrium cell E cell is equal to 0. For equilibrium cell E cell is equal to 0. For concentration cell E naught cell is equal to 0. For concentration cell E naught cell is equal to 0. For equilibrium cell E cell is equal to 0. And even they didn't ask the what is the Q and what is the QC. They didn't given equilibrium constant. So we can't say like it is a correct concept. Next, question number 74. What is that? The solubility product expression for tin 2 hydroxide SnOH2. Generally tin hydroxide undergoes dissociation. It forms the tin plus 2 plus 2OH minus. But according to our concept, what is the solubility product? Ksp is equal to x power x, y power y, and s to the power of x plus y. What is the x here? 1. what is the y is 2, means we can say 2 power 2, like this also we can write. But directly if I will write solubility, what they ask, solubility product, that is we can write 10 plus 2 power 1, and this is what, OH minus all power 2. So this is the concept. Option number 3 is correct. Question number 75. What is that? Electrode potential of an element is independent of. Direct option is stoichiometric coefficient of the species of the electrode of reaction. Direct question. Next, question number 76. What is that? Find the reaction other than AlCl3 in Friedel-Crafts alkylation. Means simply they are giving the benzene. So benzene upon react with CH4, it does not form alkyl halide. Friedel-Crafts alkylation means you should take the alkyl group. So this is wrong. NH3 is also wrong. Then if you will take RHR or CH3X, they given the CH3Cl. So this Cl and hydrogen gets removed. This R part is going to attack. So that is called the Friedel-Crafts alkylation in presence of AlCl3. If you will take CH3C double bond OCl, fourth option is, that is we will get the C double bond O, or this is the Friedel-Crafts acylation. This is called Friedel-Crafts acylation. Simple question only. Next, question number 77. What is that? Which is not a aromatic. So pyridine is aromatic, already we know that. So because pyridine contains the 4n plus 2 pi electrons is 1, 2, 3, 4, means 4n plus 2 pi electrons, 6 pi electrons. And what is that? Cyclobutane. Cyclobutane contains 4n. I will do the separate concept. 4n pi electrons is not a aromatic. The remaining already naphthalene and pyrrole are the aromatic. Already previous questions we discussed earlier this based on this concept. Next, question number 78. What is that? Which of the following is not a Lewis acid? Directly Cn minus, because AlCl3 if I will take. So this contains the vacate orbitals. To means what is Lewis acid definition first? What is Lewis acid? Acceptor of lone pair is called the Lewis acid, and Lewis base is the electron pair donor is the Lewis base. But what they asked, not a Lewis acid they asked, right? So not a Lewis acid is, we can say that AlCl3 is the Lewis acid, right? But what they ask, not a Lewis acid is Cn minus is the not a Lewis acid. Next, question number 79. Which of the following statement is true? Direct option. Hard acids are non-polarizable. So just you should read some basic points for what is hard acid, what is the properties of hard base, what is soft acid, what is the soft base properties. Pearson concept, right? So according to Pearson concept, hard acid and hard base, soft acid and soft base forms the more stable complexes, more stable compounds, right? Next, question number 80. What is that? Directly Nessler's reagent is K2HgI4 is called the Nessler's reagent. Important reagent. Next, question number 81. What is that? Which of the following ion is colored? Colored means it should be present at least one unpaired electron. We will check. Zinc plus 2 is a D10 configuration. So hence it is fulfilled. So it is not in color. Second is titanium plus 4. Titanium is, what is the titanium oxidation state? Titanium atomic number is D2S2. 4 electrons are lost. Hence it is D0 configuration. It is also colorless. Next, copper plus 1. Copper is the D10S1 system. What is the configuration? D10S1. So here S1 electron is lost already. So here it is a D10. D10 is also not a color compound. That is a vanadium plus 3. Scandium, titanium, vanadium. Vanadium is D3S2. So here 2 electrons lost, 3 electrons lost. Here 2, here 1. You will get the D2. D2 is the colored compound because it contains the 2 unpaired electrons. Whatever the unpaired electrons is there, it must possess the color. This is the concept. Next, question number 82. What is that? Which of the following is not a hard base according to Pearson concept of hard acid and soft base, right? So that is I minus. So why I will say I minus is, so if I will write, what is the asked, hard base, not a hard base, right? Not a hard base, right? First I will write the hard base. Hard base possesses smaller in size. So I will take fluoride minus chloride, bromide, iodide, and oxygen is O minus 2. These first two groups are possess the low size compared to this, also compared to low size. This is the high size, this is the I minus. I minus is the soft. I minus is the soft. What they asked, not a hard base. We obviously it is not a hard base. O minus 2 they given options. So hence it is a hard base, and F minus is also hard base because small size. So but I minus is possesses a long size, hence it is not a hard base, it is a soft base. Next question number 83. The principal oxidation state of lanthanides, right? Generally lanthanides is possess common oxidation state is +3. Just lanthanum +3 you should remember. 2, 3, 4 number, this is a +3. Minimum oxidation state is +2. Maximum oxidation state is +4. 2, 3, 4, just remember. Common is +3, minimum +2, maximum +4. In our question they asked the principal is common. Common oxidation state is +3. Question number 84. What is that? The lanthanide contraction related to. What is lanthanide contraction? So this is the group scandium, yttrium, lanthanum, actinium, right? Titanium, zirconium, hafnium, rutherfordium. Next vanadium, niobium, tantalum, dubnium. Chromium, molybdenum, tungsten, zebergium. So like this, if you observe, this is scandium is atomic number 21, yttrium is 39, lanthanum is 57, actinium is 89. So if I will write here lanthanum 71, here again continuously it is not going to start. 57 means next you will get the 72. So what I wanted to say that in this between that the F block elements are going to add here downside. So that is what lanthanum is cerium to lutetium, thorium to protactinium, uranium, laryntium, up to laryntium. 58 to 14 you should add, 71. Then so thorium is 90 to 103, you will get 103. Here cerium, right? So the cerium size is very high, first very high. Then as down the group, what happened in lanthanide contraction, down the group size is decreasing. Down the group size is decreasing means that is nothing but ionic radii. Ionic radii. It is related to ionic radii. Next question number 85. 85, important concept. Which of the following system has a maximum number of unpaired electrons? Just remember, I already told you, this is the T2G orbital, 3 orbital, if it is the EG orbital. If it is the, this is for octahedral splitting. If it is a tetrahedral splitting, just reverse it. It is the EG, this is the 3 is T2G. In between it is barycenter. Barycenter, right? What is the question? First question, D6 tetrahedral. I will write tetrahedral. D6 means 6 electrons. 1, 2, 3, 4, 5, 6 electrons. D6. How many unpaired electrons? 1, 2, 3, 4 unpaired electrons are there. D6. Next, what is the given? D9 octahedral. 1, 2, 3, 4, 5, 6, 7, 8, 9. Only D9 system, only one unpaired electron. Next, D4 octahedral low spin. This is octahedral low spin means D4, right? Low spin means just pairing 1, 2, 3. Don't go for up, just pair it. So how many electrons? In D4 low spin, LS low spin. How many electrons? 2 unpaired electrons. Next, D7 octahedral high spin. D7 system means I am writing here 1, 2, 3. High spin means now don't pair up. 3, 4, 5, 6. D7, right? This is 6, this is 7, 3. D7 high spin is 3. So now you observe. So how many number of maximum unpaired electrons is 4. D6. What is that? D6 tetrahedral. D6 tetrahedral is possesses the maximum number of unpaired electrons. Next question number 86. 86, right? The number of unpaired electrons in tetrahedral NiCO4. Tetracarbonyl nickel. Number of unpaired electrons. So how you will count it? Nickel is generally in the oxidation state 0, D0. So hence it is D0. But here you can say not D0. So nickel tetracarbonyl nickel is possess CO is neutral. You can say nickel is generally D8S2. Oxidation state is 0 means it should be continuously like this only. What is the D8 system? 1, 2, 3, 4, 5, 6, 7, 8. And this is the S system. 1, 2 electrons. But the carbonyl is the pairing. Carbonyl is the low spin ligand. Hence it gets pairing. So hence it low spin complex. Hence the number of unpaired electrons is 0. Number of unpaired electrons is 0. So this is a tetrahedral complex. Tetrahedral complex, basic example from the VBT they asked. Question number 87. Direct question. Which of the following is called the inorganic benzene? B3N3H6. Like it is forms like BNB and NBN. This is the same like benzene only. So you will get the hydrogen here, hydrogen here, hydrogen here. This is the B3N3H6. It is similar to the benzene, so it is called the inorganic benzene. Question number 88. What is that? The number of atoms per unit cell in FCC. So just I will write the how to remember the unit cells. First you should take simple cube, BCC, then FCC. So number of unit cells I am writing directly. Number of unit cells, just 1, 2, 4. So FCC is the 4. I am not going to explain the complete concept. So answer you should remember. FCC is 1, 2, 4. Next, question number 89. So which of the following compounds to be detected by Morris test, right? What is the Morris test? So you should know the reagent first. This is alpha hydroxynaphthol. In presence of concentrated H2SO4, it gives the violet color with sugars. Violet color with sugars is Morris reagent. So what is the option? So Morris test can be detected by using sugars. Sugars can be detected by using Morris test. Question number 90. What is that? Arrange the following groups based on priority of sequence rules for RS notation, right? Iodine, bromine, OH and SH. So for RS nomenclature, first you should focus on the atomic number. So compared to all, which of the following? This is OH, this is S means SH. So this is bromine, this is iodine. Sulfur atomic number is 16. Oxygen atomic number is what? Oxygen atomic number is 8. Bromine atomic number is around 79 something. Fluorine, bromine, iodine. Compared to iodine, bromine is the less atomic number. So first priority is iodine, second priority is bromine, then next is sulfur. Iodine, bromine, then sulfur SH, then OH. This is the order. First option is the correct. Sorry, second option is the correct. Simple concept. Atomic number, based on atomic number only we will give the RS notations. Next, question number 91. In butane, the methyl groups are an angle 60 degrees is called, right? Like butane, for example, if I will take CH3, CH2, CH2, CH3, this is a butane I am taking. But these are the carbons, these are the groups, right? So if I will write the Newman projections, so this is a carbon, this is a carbon. For carbon, 2 hydrogens are there. Here I am writing 1 hydrogen here, 1 more hydrogen here, 1 CH3 group, right? For this carbon is attached back side. Here again, here I am writing hydrogen, this is a hydrogen, this is a CH3. So whenever the CH3 and CH3 makes an angle of 60 degrees is called what? Gauche. This is option Gauche is correct. So if I will write opposite, CH3 and CH3 makes an angle opposite is called what? Opposite 180 degrees means it is called as, this is Gauche. This is a Gauche form. This is anti form. You can say anti. So if CH3 and CH3 are eclipsed means the angle is, here you should write theta is equal to 60 degrees, theta is equal to 180 degrees, theta is equal to 0 degrees. This CH3 and CH3 makes 0 degrees. This is called eclipsed. eclipsed conformation. This is a staggered conformation, you can say. Anti means staggered. Anti is nothing but staggered. Opposite is staggered. And this is angle 60 is, what is that? Angle 60 is called gauge. Next, question number 92. Direct question. Primary structure of protein refers to what? Amino acid sequence in protein chain. Direct question. Next, question number 93. What is that? Which of the following is determining error? This is also direct question. Determining error is a personal error. Next, question number 94. 94. Methane has a point group of methane structure is like this: hydrogen, hydrogen. This is a hydrogen, this is a hydrogen. Methane structure is tetrahedral point group. Direct question from the symmetry. Next, question number 95. What is that? The largest peak of a mass spectra is always. So if it is a percentage of abundance and mass, if you will take. So if I will in the spectra, you will get like this, some lines. So highest peak is called always base peak. So what is the given? Mass spectra is always, largest peak is nothing but base peak. Simple concept from the mass. Next concept, question number 97, right? Which of the following reagent is used in the Clemmensen reduction? Clemmensen reduction is nothing but what? If I will take ketone in presence of zinc amalgam is zinc mercury, right? Zinc amalgam in HCl, right? Zinc amalgam in HCl, you will get reducing. This is a reducing. C double bond will reduce it to CH2. This is what? Clemmensen reduction. Next, question number 98. 98, right? What is that? Ethyl acetoacetate is prepared from ethyl acetate. Ethyl acetate, first you should know. First you should know the difference between acetate, ethyl and aceto group. This is first I am writing, this is the acetic acid. If you remove this hydrogen, this is called what? Acetate. This is called acetyl group. This is called acetyl group. So you should write based on this. This is the concept I am going to write. Ethyl acetate is prepared from ethyl acetoacetate is prepared from ethyl acetate. Ethyl acetate is acetate, C double bond O acetate. This is the acetate O minus, and ethyl is C2H5. This is prepared from this we are preparing the ethyl acetoacetate, EAA. Ethyl acetoacetate is first ethyl group, same ethyl group, aceto group. First I will write, this is the ethyl group, C2H5. This is the what? Acetyl group, ethyl group. Then ethyl acetoacetate. Acetate is what? This is the acetate I already discussed. CH2 C double bond O is the acetate. Ethyl acetoacetate. So what is the reaction? Reaction is nothing but Claisen condensation. From Claisen condensation directly we can say that this is, what is the product? This is the alpha carbon, right? Attached, this is the alpha carbon, this is the beta carbon. So what is the product? Beta keto esters. This is what? Esters, right? Ester group. So we will get the product is also beta keto ester. Next question is same concept. The Claisen condensation is often used in the preparation of, what is that? Beta keto ester group. Beta keto ester. That is what? Question number 99. Question number 99 is nothing but same. The Claisen condensation is often used in the preparing what? Beta keto ester. Same concept only. Next, question number 100. Last but not least. Direct, when aliphatic aldehyde is heated with a failing solution. So nothing but aldehydes and ketones. This is a ketone or aldehydes using the failing solution. If it is failing solution is nothing but copper containing the hydroxide and compounds. Copper containing compounds, when they react with the aldehydes and ketones, so that gives the red color. Red precipitate is nothing but, so far if it is aldehyde, the question is what? Aldehyde, aliphatic aldehyde, which they give the in presence of failing reagent, which gives the red precipitate is nothing but what? Failing solution is positive. Failing solution positive. So if it is a blue color, that is ketone, that is another concept. So this is all about APPGCET 2021 chemistry complete explanation. If you like my video, subscribe and share to your friends. Don't forget to share. Okay, thank you.